All right. Hi, everyone. Welcome to my talk. I'm super excited to be speaking here today. This is my first in-person talk in over 2 years, so hopefully I still remember how to do this. My name is Paul Ganssle. You may know me from some of my open source work. I'm a Python core dev, where I usually work on datetime and related things. I added the zone info module to Python, and I maintained dateutil and setuptools for many years. In my day job, I work on a machine learning team at Google, which has a beautiful office just like 2 or 3 blocks away from here. If you ever get a chance, it has stunning views of the rivers, or just the one river, right? It's the Colorado River. I always enjoy visiting Austin. But today, I'm not going to talk about how awesome the Google office is. I'm going to talk to you about testing, and specifically how and why you would want to add tests to your test suite that you know are going to fail. I thought I'd start by clearing up a common source of confusion. If you've never heard of these things and you're not confused about them, that's fine. But I certainly came across this initially when I would go through some test suite or something, and I would see, all right, some of these failing tests are being marked as skips, and some of them are being marked as xfail. Like, what's the difference? Why are they there? There's sort of 2 flavors of difference here, right? There's a behavioral difference and a semantic difference. The behavioral difference between the 2 is that for a skipif, like skip or skipif, you don't run the test. So you'll run the test suite, and anytime it encounters a skip, it will just, none of this code will get executed. With xfail, what it does is it executes the test, and then it just marks whether it failed or succeeded. But if it fails, it doesn't cause the total test suite as a whole to fail. The semantic difference is related to this, but it's a bit subtler, right? With skipif, you're saying these tests are supposed to fail, which is why you're almost always going to be using, well, you're basically always going to be using skipif with a conditional. So it's for something like this, where in dateutil we added lazy loading for modules or for submodules, but it uses some features that are only present in 3.8 and above, and we still support older versions of Python. So we say, okay, these tests, we're not expecting these tests to pass on Python 3.7, and there's never going to be a point where we go and backport this feature into Python 3.7. So I'm just going to permanently have this skip function on this test until we stop supporting Python 3.9. For xfail, these are tests that are currently failing, but I would prefer it if they were passing, right? So also in dateutil, we have a parser that parses ISO 8601 dates. This is a particularly obscure ISO 8601 format. It allows you to have like fractional hours. No one ever uses this format. No, like people don't even know that it's possible. So when I was writing this parser, I didn't get around to adding this, but the parser is supposed to parse all the valid functions. So it's a low priority bug, but I can write a test for it, and if I mark it as xfail, it's still going to run every time, and it's just going to say, yep, you're still a bad maintainer because you did this wrong. So when I first encountered this, I mean, you may be skeptical, as I was, about why would you ever want to check in tests that are failing, right? It's kind of like checking in commented code. It seems like a code smell. I was given a little bit of pause when someone brought up a dateutil issue, and one of my co-maintainers, Brock Mendel, he said, look, I'm going to get around to this, but I like your example. Can you add it to our test suite and mark it as xfail? And I was like, why are you doing this? But, you know, whatever. I'm open-minded. He's a smart guy. And, of course, you can tell from the fact that I'm giving this talk now that I was so persuaded that just 4 years later, I'm writing multiple blog posts, and I'm trying to go on a world tour to get everybody to use xfail. So that's just a bit of a teaser, and hopefully in the next couple slides, I'm going to convince you as well. So let's start with an example. So here's some function. It's called isPerfectSquare. It tells you whether a number is a perfect square. It takes an integer. So I write this Friday in the morning. I integrate it into our thing. I add tests for it. I get really great test coverage, right? It's a parameterized test. I have one test that's like all these perfect squares, and then another set of things that are not perfect squares. I got 14 tests. Every one of them passes straight to production. This is great. I deploy it. Monday morning, I'm sitting around. I'm like, wait, I didn't test this with any negative numbers. Well, it's probably fine, right? I'll just write this test. It's just going to say it's a negative number, so by the domain of the function, it's going to be false. But no, it's actually this value error, and that's not the intended semantics of the function. So now I have this failing test, and I'm like, well, here's the thing. We never use this with negative numbers anyway. It only gets ever called by something that uses uses positive numbers. And I've got 5 other things that are on fire because I pushed to production on Fridays. What I'm going to do is I'm just going to say, I'll fix this later. But I've already written a test. I might as well check it in because I'm obviously the sort of scatterbrained person who can't really keep track of his schedule and things like that. So what I'm going to do is I'm just going to mark it as xfail. I'll just like slap some parameters on there and say, all right, at some point this test should start passing, but it's not passing now. And what happens is when I start running the test suite, it'll run and it'll say, oh, look, there's 3 little x's, 3 things x failed. Yep, it's failing just like you expected. Wednesday morning, I'm like, oh, wait, why was I putting this off? It's 2 lines. If n is less than 0, return false. I could have just done this on Monday, whatever. So I implement this, and what should be happening is that now my, well, that should be 3 x's. Again, it's been a couple of years. Anyway, it should be saying that I have 3 x passing tests, right? It used to be x failing. Now the little x turns into a big X, and it's saying it's x passed, which is to say I expected a failure, but it was a pass. So now this is notifying me I fixed the bug. But here's the thing. Whenever I'm running my tests, it's usually run in some CI matrix, right? It's like run on 5 different platforms and a bunch of different things. I'm not manually reading the pytest outputs and noticing when the little x's turn to big X's. So what I would really like to do is to treat failing to fail as a failure. I'm going to give you a second to parse that. So luckily, this is supported. I mean, I want to pretend like this is a good thing that it's supported, but honestly, this should be the default, in my opinion. So what you can do is you can take your xfail marker and you say strict equals true, and what that's going to do is it's going to say if there's an x pass, that is actually a failure mode. So normally, you might think like, I don't really want my test suite to start failing more often, so why would I do this? I'll just remember to remove the xfail decorator. But that's kind of the point, right? You may not remember that you even wrote this test, right? Maybe you wrote it on Friday and then you went out drinking and you forgot about it. Or maybe this test was written 5 years ago and you accidentally fixed the bug, right? You just refactored something and this test was only failing because of some implementation detail that's no longer relevant. And so what will happen is, as soon as you fix the bug, your test suite starts to fail. You go to the failure mode thinking, I'm going to have to debug some stupid hairy thing, and it's actually saying, hey, remove me. I've written your test for you. Isn't this great? So that's why this should be the default. Luckily, pytest makes it easy to make it the default. Well, I mean, easy is a relative term because there's at least 3 different ways you can do your global configuration, plus conftest.py and whatever. But wherever you do your configuration, all you have to do is add xfail_strict equals true, and you're good to go. Every one of your xfail markers will automatically be strict unless you turn it off by specifying strict equals false. The other thing is, I sort of tricked you, right? Because when I wrote this parameterized test, I said, oh, it's going to start x passing. That's going to be great. But I deliberately made a mistake here. Because if you look, the parameter is named n, but when I called it, I put isPerfectSquare m, right? So this test never started passing when I fixed the bug. It continued to xfail, and I was never notified of this. And the reason for that is because this is actually failing because of name error, not because of the value errors I was expecting. This is actually something you can enforce by being a little bit more specific about why the test is failing. So what you do is you just take this raises parameter and you pass whatever error is supposed to be raised. You can't be amazingly specific about this, but this will actually cover a decent amount of the sort of different failure modes, right? You're either going to say an assertion is going to be failing, in which case that is assertion error, or it fails with some specific error type, and maybe it's failing with the same error type for a different reason, but this is better than nothing for sure. So once you have this, you have this sort of library of tests that are going to start failing if you accidentally fix them. But maybe that's not really a problem that you have in your life. But I still think that there are many reasons to care. So one of them is that when you use xfailing tests, whether you fix it right away or a year later, what you're doing is you're documenting your acceptance criteria, right? You're programmatically saying you can close this bug when this test starts to pass. So you check it in and you label it with the bug, and then once that test starts passing, you remove xfail and close the bug. This is great. It's much more specific than, you know, some issue tracker. It could be someone put a bug in an issue tracker, then they leave the company, and 3 years later you're like, I don't know, is this still relevant? You know, you also don't necessarily know if the bug's been fixed in the past 5 years or something. This also lets you test your tests in a way, right? The TDD proponents, the test-driven development proponents, are always saying, like, you should write your test first, and then you write the thing that fixes it. Well, this is a sort of longer separation between that, right? You write the test first, you make sure that it's failing, and then once you fix the test, you know that you have a good regression test, right? Because if anything goes backwards, that test, which is no longer marked as xfail, is now going to start being just regular old failure. You also get to impose your regression tests immediately, right? Again, this may not be a problem you have, but for like a huge code base like CPython, it could easily be the case that someone accidentally fixes some obscure bug and then introduces the same bug or a similar bug later. If you had xfailing tests for those things as associated with a lot of these bugs, what would happen is as soon as you fix the bug, you have your regression test immediately and you never get a regression. The other thing is, adding these xfailing tests might not be as costly as you think, because if you're writing good bug reports, it's not actually that, you sort of get a lot of this for free. This blue text here, and I encourage you to check out the slides so you can get to this link. This is a link to Matt Rockland's blog post on crafting good bug reports. And in that he says that your bug report should contain an example that is complete, which is to say that it has as much code as you need to reproduce the issue. Minimal, which is to say it should have as little code as you can get away with that still reproduces the issue. And it should be verifiable, right? Which is to say that anyone who comes across this example should be able to just reproduce your issue. And these are exactly the same properties that are a good test, right? It's a very small, self-contained way to reproduce the issue, and you're just checking what the output is, right? So hopefully, what you can do is you write a good bug report. The maintainer says, this is great, I would love to fix it. And then you just take that example and you plop it right in the test suite and call it xfail, and they merge it. Another nice feature of that, right, is that if you're a maintainer, you can really signal to your users, I care about your issue because, you know, you're saying, I'm kind of committing to fix this in some way by saying, I'm going to accept your acceptance criteria, I'm going to put them directly into my test suite, and hopefully one day I'm going to look at all those X's and say, I really wish those X's were dots, and go fix them. Okay, so now that we've gotten through the why, I thought I would go into a little bit more about the how. The basic use of this is with a pytest marker. Pytest is kind of weird. They have these decorators that are like marks, and then you can also have custom marks. And then there's fixtures. It's a little confusing, but basically, you know, treat these as decorators, and they're under this mark namespace. So with xfail, you have the bare decorator, which is you don't have to put anything. You can just mark it as xfail. You can also say a reason, so that it'll say xfail as part of your verbose text output. It'll say exactly why. Usually, it'd be nice to put like a bug tracker number there. There's also this skip decorator that is the equivalent of these things, but you never use skip. Like, I think the main reason that this is included is that so you can like compose it with other stuff to make other decorators that have like more complicated conditionals. So basically, always use skipif, never skip. So moving on to skipif, xfail itself is kind of equivalent to skipif in that it takes a Boolean condition as the first parameter. It's an optional first parameter. And skipif takes a Boolean condition. The reason parameter is required if you use a Boolean condition. And yeah, obviously, you can understand why you would want Booleans, right? Skipif, you pretty much should always be using conditionals because otherwise, why would you put the test in place? It's never supposed to start passing, and there's no platform on which you would run it, so just don't write it. With xfail, you can imagine it's kind of important to have a conditional because especially if you're using strict XPath, right? Say you have something that starts breaking in Python 3.10, you're working on Python 3.10 support, and you want your test suite to start passing, you would say, okay, Python 3.10 and greater, this is xfail, otherwise it's a regular pass. So you can do that. It's very encouraged that you use this Boolean format with the reason. There's also this sort of legacy format, which I guess is never going to be discontinued, but it's discouraged, where you can specify your Boolean as a string, like a conditional string. And this is just going to get evaled in some weird namespace. I don't know. And the main reason for doing this, as opposed to the Boolean, is that it will take this conditional string and put it as the reason. So when you look at your output, it's sort of a self-documenting thing. I think it's probably better to just put like a bug number or whatever. All right. Other things in the markers, xfail has this weird thing that it took me a little bit to understand why you would want this, is the run parameter. So with xfail, you can specify run equals false, and it will essentially turn xfail into a skip, behaviorally speaking. So it'll say, don't run the test. I think you mainly would want this if you want to semantically mark your thing as xfail, right? So you're saying, at some point I want this xfail decorator to go away, but for whatever reason, you actually can't run the test, right? Like the failure mode is that the interpreter is going to seg fault, and like pytest can't recover from that. Or the failure mode is that it's some like runs out of memory situation, right? You have some parser, and if you have 17 like curly braces in it, it uses all the memory in your computer, right? Obviously, you don't want to run that just to see if it starts passing. So you would put run equals false. And interestingly, there is this this thing where you can run pytest with -- run xfail, and it'll ignore all the xfail stuff and just run all the xfailing tests. I've never thought that I would need that sort of thing, but if I had tests like this, it might be nice to be like, all right, every 3 months I'm going to like run this and make sure it's still seg faults. When you're working with parameterized tests, it's a little bit more complicated to add these marks because, I mean, the one option you would have, right, is that if you have, say, a test and you parameterize it and there's 4 different parameters and on 2 of them it's failing for 2 different reasons or something, right? You could imagine like just copy pasting this test 3 times and then marking one of them as xfail with one way and then one of them with xfail another way. But pytest has this other thing, which is pytest.param. It's just like a wrapper for whatever parameter, and you can attach attributes to it, including marks. So I always have to look this up, but once you know it exists, it's pretty easy to look up. So you just take your parameter, you wrap it, and you say what marks go, and it's essentially the same as doing a decorator that only applies to the specific parameter that is being used in that particular execution of the test. There's another way that you can use xfail and skip, but this is not super recommended. It's the imperative form of xfail. So normally at sort of test collection time, you're adding markers to the functions themselves, and these decisions happen before the function is executed. You can also just call a function inside of your test function that will change the function that's being executed to a skipped or an xfailed test. You might want to do this if it's kind of difficult to determine whether you need to skip or xfail until the function is run. Probably the more common use case, or like the better use case, would be if you have a function, like a test function or a context manager or a fixture, where maybe it needs access to some external resource or something like that, right? What you can do is, for example, here I have this context manager that you would run a section of your test as in another time zone. But there are some platforms where you can't change the time zone, or like changing the time zone changes it globally for all users, and you're like, that's not happening during my test run. So what you could do is you can write into your context manager, all right, if I'm on one of these weird platforms, call this skip function, and then later in my function that says, okay, I do my test in New York, I don't have to remember what the condition is and then apply it. It just happens automatically when I try and enter that context. the containing test function will be marked as skip. But that's much more useful with skip because with the pytest.xfail has kind of like not great semantics because the pytest.xfail imperative form, it basically is a skip. It stops execution immediately. There's no way to get xpass. Xfail strict has no effect. There is a solution to this. Brian Ocken wrote this this fixture or this plugin called pytest runtime xfail, and what this does is it's just xfail but with the semantics you would hope for. It will continue to run the test. So if you want to use something like this, if you have a use for it, I recommend this plugin. It seems pretty good. There's another Papercut, which is really unfortunate, which is if you use Hypothesis, which is a property testing framework, it doesn't really work that well with xfail. So if you're not familiar with Hypothesis, the idea is that you tell Hypothesis what your inputs are going to look like, right? You say, all right, this is a function that takes integers, so just give me integers. It's going to give you all kinds of weird integers, and you make an assertion about properties of your function. So in this case, I've said, my function is such that if you give me an integer, the result is going to be an integer that's larger than the input integer. But I've written this function improperly or something, and 0 and negative numbers don't work. So this is exactly the kind of thing where you would expect it would be really nice to imperatively mark your function as xfailing, right? Because you don't even know what your inputs are going to look like until you get them. So it would be nice, and Hypothesis is very persnickety, right? Like you slap Hypothesis tests on something and you're like, yeah, this is going to be well tested, but also you have to fix every little edge case right then. It would be very nice to be like, okay, this works in like 99% of the case, but there's like a couple parts of this domain of inputs where it's just not working and I'm not going to fix it right now. But unfortunately, so this seems perfectly fit for xfail, but the problem is, I think just based on the way Hypothesis is implemented, this is only ever going to report a single top-level xfail, which is especially bad because it disguises real failures. So if this test were failing in like 90% of cases and it hits one xfail, it's still going to be reported as an xfail, not as a failure. And I tried to get it to work with pytest runtime xfail, but this is a function scoped fixture, and Hypothesis doesn't work with that, and I'm not sure that there's a way to work around that. This may be a fundamental failing of Hypothesis. So, if you're very excited about xfail, it might be interesting to work with the Hypothesis maintainers. They seem really nice to try and get this working, but until then, it's just kind of a paper cut. All right, so far, I've just talked about pytest because I love pytest, and also pytest does this very well, as they do many things very well. But maybe you work for some company or that started doing a lot of Python testing a long time ago and now has a huge code base and a giant building with a huge G on it 2 blocks away from here. And now all their tests are written in unit test or some unit test derivative, right? Or maybe you work on the CPython code base, which doesn't pull in third-party dependencies like pytest and instead uses unit test. And maybe you're chafing under the fact that you can't use this xfail. I would love to say that, like, great news, unit test has perfectly equivalent functionality. But in reality, they don't. They have something close that kind of works. There is this expected failure decorator that gives you the xfail functionality. It doesn't take any parameters. You can just mark something expected failure or not. Here's what it looks like when you run it with unit test. For expected failures, it marks it as expected failure, and that won't to failure test suite. For X passes, it calls it unexpected success, and that fails the test suite. So it actually has the strict equals true behavior by default. Sometimes what you do is you write your tests in unit test and run them with pytest. Here's what that looks like. PyTest doesn't, I think, have really any way to interpret that unexpected success as an XPass, so that's always going to be a failure, and I don't think there's any way to change that. But, it doesn't totally choke on it. So this is a viable alternative if you can't convince people to switch over to pytest. The missing feature specifically for this is there's no way to set strict equals false. You can't do run equals false. You just have to do a skip. In 10 minutes of playing around with it, I found no way to implement the raises behavior, so you can't be terribly specific about why it's failing. You can't specify a reason string, so you're going to have to use comments to say which bug it's associated with. And there's no conditional xfail built in, which seems like a very odd missing feature considering that strict x passing is also on by default. So, but luckily, it's like super easy to implement this. It's just like you write your own little decorator that returns the expected failure decorator if the conditional is true, and otherwise returns the function itself. And I don't know. Maybe there's some core dev that we could persuade to try and get this into the library, but I have not looked into this at all to see why this was not implemented. It might be like half the time when I go to do something in CPython core, it's like, this seems like it should be so obvious. And then like some super smart person like 15 years ago was like, no, there are like 16 different reasons why this is going to fail on 3 different platforms, and we just fundamentally can't do this. And you're like, I really respect that. Arr. So what are you going to do? With unit test, there's better support for skipping. They have this unconditional skip decorator, but even they document like you shouldn't use this. This is really only used to write your own decorators that skip in specific other contexts. They have skipif, and oddly they have skip unless. I'm not sure why these are duplicated. It seems like you could just make the first one by putting a not in the condition in the second one. But maybe some people just like it aesthetically. I'm not going to complain about it. It seems fine. There's also 2 ways to do imperative skipping. It's possible that the method came first. I'm not actually sure why you would why they need 2 different ways to do this. I know that the first one is to call self.skipTest, right? And that's a method on the test case, so you can really only use that from within a test. The second way to do it is to raise unit test.skipTest, and that is convenient because you can write a function or that context manager I mentioned, and when you raise it, you don't have to have a reference to the test case that it's on, so you don't have to have that self parameter. So you can write just sort of generic functions unmoored from any instance of a test case. It could be that the self.skipTest came first, and then the second one filled in the gaps, and you should always use the second one. But I try not to use unit test too much. All right, so we've reached the end of the talk. It seems like I made it through. I'm not sure. I might stumble. There's like still a minute to go. I thought I would summarize a little bit. If you take anything away from this, it should be maybe that X fails for tests that you know are failing but shouldn't be. Skip should always be used conditionally because that is for tests that are supposed to pass, that aren't supposed to pass. And you should always set X fail strict equals true. When I first put this talk together, it had a whole bunch more slides because it turns out that I could talk about expected failure stuff for like a surprisingly long time. I really thought it was going to be 20, 25 minutes tops. But I have actually 3 blog posts on this. So this talk really only covered the first one. If you want to learn some real persnickety stuff about X failing and code coverage and things like that, those next 2 blog posts are something that I would recommend you look into. I also talked about those blog posts on Test and Code with Brian Ocken, so if you prefer to listen to it, just download that podcast. And I guess I hope I've convinced you a little bit that you should start accepting expected failures as PRs, because I will say that the one big thing about this, maybe I look at this as an open source maintainer, but this really seems like an easy win for getting new contributors on board to your libraries, right? Because they come with some sort of example that says like, oh, I really wish this was working. And I feel like it's a little bit of a booster to say like, this is a valid contribution. I would really like it if you made a pull request. You don't have to fix it. You don't have to know how to fix it. I just want it to be in the code base to make it very clear that I want to fix this thing. So it's good for you, it's good for the health of your code base, and it's good for your contributors. Okay, thank you so much for listening to my talk.